Hey friends, this is Vidhan. Welcome you to my channel. Today we have a problem from December 2013, question number 40. It says, consider the melting transition of ice into water at constant pressure. Now, which of the following thermodynamic quantities does not exhibit a discontinuous change across the phase transfer? Internal energy, Helmholtz free energy, Gibbs free energy, entropy. Ice is changing into water at constant pressure and at constant temperature also. The reason is 0 degree ice is changing into 0 degree water. So temperature is also constant here. So in this problem it says ice is changing into water at constant temperature and constant pressure. We already know this is first order phase transition. Phase transition. We may also say phase transfer. Ice needs heat, latent heat, to change into water. And we know in a process of phase transfer, if heat is released or heat is absorbed, then that is called first order phase transition. And since in this process heat will be absorbed by ice to change into water, so it is a first order phase transition. And we know two basic points about the first order phase transitions. They are entropy changes discontinuously in first order phase transition, and we also know that volume also changes discontinuously in first order phase transition. So these are the two basic things that we know. Now in our problem it says whether internal energy changes discontinuously or not. So we need to find this out. Now we will see whether internal energy changes discontinuously or not. So we will see a little bit of derivation for internal energy, and we will check whether they depend on entropy or volume or not. If finally internal energy becomes a function of entropy and volume, and since entropy changes discontinuously and volume changes discontinuously, and if internal energy is function of any one of them, then internal energy will also change discontinuously. Now let me tell you how. So first of all, a little bit of derivation for internal energy, and we know how to derive for internal energy. First of all, let's take the first law of thermodynamics, that is dq is equals to du, where u is the internal energy. Actually this is change in energy, this is change in internal energy, this is the amount of energy that is given to the system, this is change in internal energy, and this is the work done. We know the second law of thermodynamics, that is ds is equals to dq by t. From here we have tds is equals to dq, and in place of dq we will write down this du plus dw. We want to find du, so let us take it to left side. Du is equals to tds minus dw, and we know dw is p dv minus p dv. And from here we can see that change in internal energy depends on the change in entropy and change in volume. That means these are the variable terms, so internal energy depends on entropy and volume. Now since entropy changes discontinuously, so internal energy also changes discontinuously. It also changes discontinuously. Now we can also say that it depends on volume, and since volume changes discontinuously, so again it changes discontinuously. And in our problem it says which one doesn't change discontinuously, that is what we need to find. So internal energy changes discontinuously for first order phase transition. Now For the second one, Helmholtz free energy. Now since this is also one of the potential, thermodynamic potential, and this is also one of the thermodynamic potential, so let us check for all. Now second, we will see for enthalpy, even if it is not given in our problem. We will just check it out. So let's see whether enthalpy changes discontinuously or not in first order phase transition. So for that, we already know that enthalpy is H. H is equals to enthalpy U plus PV. Now we will differentiate both the sides. So dH is equals to du plus dp p dv plus v dp. Now in place of du, we will write this down. TdS minus pdv. So this part has been written in place of du plus pdv plus vdp. We can see that minus pdv plus pdv cancel. So dH is equals to TdS plus vdp. So this is the final relation for enthalpy. And now you can see that enthalpy, change in enthalpy depends on the change in entropy and change in pressure. So we can say that enthalpy H depends on or is a function of entropy and pressure. Okay, so in first order phase transition, we can see that temperature is constant and pressure is constant. So pressure is constant. It depends on pressure, so pressure is constant, but you can see that entropy changes discontinuously in first order phase transition. Now since one of the variable changes discontinuously, so H, enthalpy, also changes discontinuously. Okay, now we will see for Helmholtz free energy. F. Helmholtz free energy. Now we already know that F is equal to U minus Ts. From here, differentiating both sides, dF is equal to du minus Tds minus sdt. Now again, we will use this du from here. So du equals to Tds minus Pdv. Tds minus Pdv minus Tds minus sdt. Now you can see that here plus TDS and minus TDS cancel. So we have dF is equals to minus PdV minus S dt. So from here we can see that change in Helmholtz free energy depends on change in volume and change in temperature. So these are the variables, temperature and volume. That means from here we can see that F is a function, or F depends on volume and temperature. Now temperature in first order phase transition is constant, as we have already seen, but volume changes discontinuously. It changes discontinuously. So since one of the variable changes discontinuously, the Helmholtz free energy also changes discontinuously in first order phase transition. First order phase transition. Okay, now let us move to Gibbs free energy. gives free energy G. We know G is equals to H minus Ts. Now again differentiating both sides, Tds minus S dt. dH minus Tds minus S dt. Now we will write down in place of dH, we will write down now you can see that dH equals to Tds plus Vdp. This is what we will write down in place of dH here. So here we have Tds plus Vdp, then minus Tds minus SDT. So minus Tds and plus Tds cancel. We have dG is equals to Vdp minus SDT. Now from here you can see that change in Gibbs free energy depends on this variable, pressure, and depends on temperature. So from here you can understand that our Gibbs free energy depends on or is a function of pressure and temperature. And we know that pressure is constant in first order phase transition and temperature is also constant in first order phase transition. And therefore, since pressure does not change discontinuously, temperature does not change discontinuously, so Gibbs free energy does not change discontinuously. And we may say one more thing, that since G doesn't depend on volume and entropy, we know that volume changes discontinuously, entropy changes discontinuously, and G doesn't depend any one of them, so it doesn't change discontinuously in first order phase transition. So from here it is clear that our first option is about internal energy, second option is Helmholtz free energy, third option is Gibbs free energy, and fourth option is entropy. So third option is right, Gibbs free energy. How? Let me tell you once again that we already know the first order phase transition, entropy changes discontinuously and volume changes discontinuously, but temperature and pressure are constant. Now internal energy depends on entropy and volume. Since entropy changes discontinuously and volume also changes discontinuously, so internal energy also changes discontinuously. Now for enthalpy, since enthalpy depends on entropy and pressure, even if pressure is constant in first order phase transition, but entropy changes discontinuously, and since entropy changes discontinuously, so enthalpy changes discontinuously. Then we saw for Helmholtz free energy, and we saw that it is a function of volume and temperature. Even if temperature is constant, but volume changes discontinuously in first order phase transition, and therefore Helmholtz energy also changes discontinuously. So internal energy changes discontinuously, enthalpy changes discontinuously, and Helmholtz free energy also changes discontinuously. And then the fourth type Gibbs free energy, that depends on pressure and temperature and both are constant. It doesn't change discontinuously, it doesn't change discontinuously, and therefore G also doesn't change discontinuously. And we may also say one more thing, that since it doesn't depend on V and entropy, volume and entropy, and therefore it doesn't change discontinuously. So our answer is only G. Answer is C, Gibbs free energy. Now let me write down here in a more clearer way that internal energy, since it is a function of entropy and volume, so it will follow the entropy and volume. That means since entropy changes discontinuously, so internal energy also changes discontinuously. Then enthalpy, which is a function of entropy and pressure. Now again it depends on entropy, and entropy changes discontinuously, so enthalpy changes discontinuously. It changes discontinuously. Then we saw Helmholtz free energy, that is a function of V and T. Now there is V and V is the volume. Volume changes discontinuously. So this Helmholtz free energy will also change discontinuously. So it also changes discontinuously. So all the above three change discontinuously. But the fourth one, that is Gibbs free energy, which is a function of pressure and temperature. That means it is not a function of entropy and volume, and therefore it doesn't change discontinuously. It doesn't change discontinuously. Okay, and if we talk about separately entropy separately, then it changes discontinuously. And if we talk about volume separately, then it also changes discontinuously. So these are the things you need to remember, and our answer is C here. Thank you.